So the question asks us to find the value of the second derivative of xy plus y squared equals 4 when x equals 2 and y is positive. Let's actually graph it first to see what's going on before we actually try to find the value. So what I do is I just copy our function expression and try and graph it. But if I graph it using this tool, it's not going to work because we don't have an explicit expression for y in terms of x. So what I need to do is I need to go to Compute, Plot 2D and Implicit. And what it does is it graphs it for me. Now I can see that this graph has got two arms, one on the positive side of the x-axis, one on the negative side of the x-axis. That's why the question said, give it to me in terms of positive y. So now I'll find that y value. Looking at the graph, when x equals 2, I can see that the y value is around 1 point something. So let's go ahead and find that value. So I take this again, copy it, and the question tells me that x is 2, so I can just replace x with 2 there, and then if I solve for y, I'll get the value of y that I want. So it gives it to me in third form. The one I want is the positive one, and so negative 1 plus root 5 is going to be positive. I'll find that value as a decimal to make life easy. So expressing that as a decimal, I get 1.236, and what I'll do is I'll take that correct to 3 decimal places. So in summary, when x is equal to 2, y is equal to 1.236. Now, I want that so that I can find my value of dy dx, because I need that for the second derivative as well. So I go up to my expression for dy dx from before. Here it is, and substitute in the values that I've got. So y was equal to 1.236, x is equal to 2 on the bottom, plus 2 times that y value, 1.236. Evaluate that, and I get negative 0.276. And remember, the graph showed us that the first derivative is negative, so that makes sense. Once again, I'll correct to 3 decimal places, which will be sufficient for this problem. So now I have an x value, a y value, and a dy dx value. I can go ahead and find the second derivative value. Now, when I have a look at the graph, the top arm there is concave up, so I expect the second derivative to be positive. Let's go ahead and find that positive value. So here's my expression for the second derivative. I just now substitute in what I know. My x value was 2, and I multiply that by my dy dx value, which is negative 0.276 from above. Then I add the y value that I got, 1.236, and I put it all over x equals 2 plus 2 times 1.236, and I have to square all that. And so the value that I get, which I'll put on the next line, is 8.940 times 10 to the minus 2. And writing that not in scientific notation, it's going to be 0.0894. And that's the answer. So I can conclude that the second derivative is 0.0894, and that's the end of the question.